Okay, class. Today we're going to finish up graphing um, our cotangent, and you'll see that it's similar to the graphing of the tangent. So we're going to start off just like we did with sine, cosine, and tangent by generating an xy table. So if we have y is equal cotangent of x, xy is cotangent of x. Okay, so we're going to take a look at some values here. Because cotangent is x over y, when x is equal to 0, cotangent is going to be 1 over 0, which is undefined. So that's going to give us an asymptote. When cotangent is, now we're going to try to get close to 0. When cotangent is pi over 180, which is 1 degree, and we're going to get about 57. When x is equal to pi over 36, which is 5 degrees, we get about 11.4. When x is pi over 18, that's going to yield about 5.7. When x is pi over 9, we end up with about 2.7. At pi over 6, and that's one of the values from our unit circle, cotangent of pi over 6 is about square root of 3, which is roughly 1.7. At pi over 4, cotangent is 1. Pi over 3, cotangent is square root of 3 over 3, 1 over square root of 3, is about 0.56. And when x is equal to pi over 2, cotangent is 0. And x is equal to pi over 3, cotangent is negative square root of 3 over 3. And then as we build ourselves towards pi, the measures are just going to be negative because in the second quadrant cotangent is negative. So at 3 pi over 4, cotangent is negative 1. At 5 pi over 6, cotangent is negative square root of 3. Eight pi over 9, cotangent is negative 2.7. 17 pi over 18, cotangent is negative 5.7. And then finally at pi, cotangent is 1 over 0, which is undefined. So at 0 and at pi, we're going to get vertical asymptotes. The graph looks like this. So we're going to get vertical asymptotes at 0 and at pi, halfway between 0 and pi over 2. At pi over 2, cotangent is equal to 0. At the quarter way, so between 0 and pi over 2, which is pi over 4, we see that cotangent is 1. And at the 3/4 way, so that's the halfway point between pi over 2 and pi, we see that cotangent is negative 1. And what we notice is closer to 0, 1 degree, we're at 57. So this is unbound it, so it's going to go towards our asymptote there. So our graph is doing this. So 1 period for cotangent is pi, because we know the period is pi over b. In this case, b is 1, so our period is equal to pi. So we get 1 period here. So as we go to 2 pi, we know the period of pi, halfway in between here, 3 pi over 2, and we know that our graph is going to do the same. And it's going to keep repeating. Okay, so here, period is pi. We have vertical asymptotes at 0 and pi. We notice that our x-intercept is midway between the asymptotes. And also, that 1/4 of the way in our period, y is equal to a. And 3/4 of the way, y is equal to negative a. So very similar characteristics to that of tangent with all of those values. Okay. So now let's take a look at graphing cotangent of y is equal a times cotangent of bx minus c. So what does that yield? So y equals a cotangent bx minus c. And again, here we're going to say b is greater than 0. So step 1, we want to find 2 consecutive asymptotes. That's just like we did with the tangent. So we want to, but with tangent we went from negative pi over 2 to pi over 2. Cotangent, because the period is between 0 and pi, it's going to slightly change up. So finding the 2 consecutive asymptotes by finding an interval containing a full period, containing 1 full period. Okay? And the way we're going to do that is we're going to set 0 less than bx minus c less than pi. Whereas for tangent, it was pi over 2 less than bx minus c less than pi. Okay, we're going to solve that for x. Step 2, we're going to identify the x-intercept, and that's midway between the asymptotes, between consecutive asymptotes. Step 3, the points 1/4, 1/4, and 3/4, 3/4 of the way between the asymptotes. are a and negative a. So y equals a, y equals negative a, respectively. Okay, and then we can repeat steps 1 through 3 to graph more periods. So repeat steps 1 through 3 to graph more periods. Alright, so let's take a look at an example here. Alright, so again, find two consecutive asymptotes by setting bx minus c greater than 0 less than pi, because the period of cotangent is pi. Identify the x-intercept, which will be midway between the asymptotes. The quarter point, y will equal a. The 3/4 of point, y will equal negative a. And then we repeat steps 1 through 3 for more values, or more periods. Okay, so let's take a look at this graph. Y equals 3 cotangent of 2x. Alright, so step 1, we're going to find our asymptotes by going 0 less than bx minus c. So here, this is just 2x less than pi. We divide everything by 2. We're going to end up with 0 less than x less than pi over 2. Alright, so our period here, our asymptotes are going to be at 0 and pi over 2. Alright, so our x-intercept will be halfway between 0 and pi over 2. So halfway between 0 and pi over 2 is pi over 4. Now, a is equal 3. So let's take a look at what our graph would look like. So that's 3 there, and here's negative 3 here. So we're going to have an asymptote at 0. We're going to have another one at pi over 2. Pi over 4, halfway between, we're going to have an x-intercept. So halfway between 0 and pi over 4, well, 1/2 pi over 4 is pi over 8. So at pi over 8, we're going to be at 3. Okay, 3 pi over 8, we're going to be at negative 3. So then our graph does this. Something like that. Oh, that's awful. Still awful. Alright, something like that. Hopefully your graph turns out better than mine. But we could have found our period from the start because we know the period of cotangent is pi. So the period is equal pi over b, which is pi over 2. We use this method, though, to determine, we know the period is pi over 2, but we use this to determine where we start. And in this case, because we didn't have our c is equal to 0, we started at 0. Alright, let's take a look at one more example. Okay, one more example. Let's go y is equal 1/2 cotangent of, well, let's go 3x minus pi. Okay, so here, step 1. So by the way, our period, so A is 1/2, and our period is going to be pi over B, so pi over 3. So that's going to be our period. So now we want to know where we start to find two consecutive asymptotes. So we're going to go 0 less than 3x minus pi less than pi. Okay, so to solve this for x, we're going to add pi to all of our sides. We're going to get pi less than 3x less than 2 pi. Now we're going to divide everything by 3. And that's going to yield pi over 3 less than x less than 2 pi over 3. So our consecutive asymptotes are going to be between pi over 3 and 2 pi over 3. That period is still pi over 3. So when we go to graph this, okay, so at pi over 3 and 2 pi over 3, we're going to have vertical asymptotes. Okay, now our halfway point between, we are going to have an x-intercept. But what exactly is that point halfway between? Okay, so we know this is halfway between, but what is the point? Well, it's the midpoint between pi over 3 and 2 pi over 3. So pi over 3 plus 2 pi over 3 divided by 2 will give us the midpoint. So this is 3 pi over 3 divided by 2, which is 3 pi over 6, which is pi over 2. Alright, so that's our midpoint there. Now, halfway between pi over 3 and pi over 2, our y value is going to be a. So a is 1/2. And our 3/4 point, which is here, we're going to be at negative 1/2. Now, in order to find what these values are, we can find, again, go with the midpoint, pi over 3 plus pi over 2 divided by 2. And for this one, we should end up with 5 pi over 6. Okay, and, I'm sorry, 5 pi over 12. And this one will be 7 pi over 12. So try it, and that's what you should end up with. So our graph is going to look like this, where your period is pi over 3. X-intercept at the midway point there, which is pi over 2. Quarter point, which is the midway point between your asymptote and your midpoint there, is 5 pi over 12, so that's 1/2. And then we were able to find the 3/4 point. Okay. Alright, so you only have to do 13 through 23 odd, which is our cotangent.